Hello, everyone. In this session, I want to talk about more advanced and more efficient ways of collecting information from Revit's database. Um, in the previous classes and sessions, we talked about how to collect some information, like, for example, walls from the Revit model that we currently have open. If we look at that script, this is a new script that I've written for this session, but it has some component that I've borrowed from the other classes. So in the previous classes, we asked for a filter element collector that we talked about in the previous sessions, and we instantiate that with a document object, and we filter down to off the category, for example, the walls, and we'll filter down to the actual walls, not the wall types, and later to the final elements. And we put all this information inside this wall object, which this is basically an instance of this filter element collector object. And then we would iterate over the walls in a sort of like an IronPython loop, and we would get a parameter, for example, in this case, the unconnected height of the wall. And then we would compare, check for the value, and if the value was what we wanted and what is intended, we would add it to a different list, and then we do something with that object. The nice thing about this is that this is Python, which is we are executing the Python script inside an IronPython engine. IronPython engine has been written using C#, and it's developed for the .NET platform. So what's nice about it is that when this code gets, basically when the IronPython engine reads this piece of text file that we have and translates this piece of code into the CLR bytecode, which is the underlying bytecode common to all the .NET languages like C#, Visual Basic, and also IronPython. It's as fast as C# really. But still, when you think about it, let's say you're running this script on a model that have like thousands of walls. Then you know that you're iterating over a lot of different objects and getting their parameter and checking the value and things like this. In the previous session about when we talked about Revit's model as a database, we talked about a concept which is basically querying the information or reading the information from a database management system. We thought of Revit as a database management system that manages the database inside the Revit model. So, and we're already using a filter element collector that basically Revit provides to us to query all the walls in the model. But what we want to talk about in this session is the other properties of this object that gives you a lot more finesse and control over what objects you want to collect from the model, and kind of like filtering them down. The benefit of this is that we are using the efficiency and the advances that have been built into the Revit itself, which is Revit its own is sort of like its own database management system. So if we ask Revit for a very specific set of objects, then we would potentially get the results a lot faster, because Revit, as I later explained, indexes information and things like that, and it knows its own database. So it's a lot faster for Revit itself to go through and find a bunch of objects for us, instead of us getting everything in the model, like for walls, and then filtering over them ourselves. This makes a lot of sense just reading the file, reading the script. Yeah, get the walls and do this. The other method that we're talking about it today is a lot more complex looking, but it has a lot of benefits over the course of, like, if you're running this script on big models and you want it to be efficient and stuff like that. I'm not trying to say that this is the wrong way to do it. This is very nice because this is a simple script that we write and we run it on our model. Everything is fine and we get the job done. But if you intend to use this script over, like, period of time, and you want to make it into a sort of like its own tool, being able to process like lots of information from bigger models that you have in your company and things like that, it's worthwhile to think about what improvements we can make to different steps to make the scripts faster, more efficient, use less memory, and basically you do less steps to get to do its job. So based on this information, the stuff that we talked about, I want to go and sort of like give you a better overview of the filtered element collector object. So when we, I'm going to actually show you here. So as in this, sample script, I'm not going to run this script in Revit. This is just my sketchpad basically. I'm importing the Autodesk Revit DB as DB, and I'm using DB to basically as the namespace for all the objects inside the Revit DB namespace. This is a very good practice for doing this. Try to do this instead of explicitly importing everything from the DB. And then I'm creating the document object, getting the document object from the Revit handle that we have. You have seen this in previous scripts that we have written in these sessions. And I'm creating a collector object, passing it the document object because I want this filter element collector to work on this document. And then filtering down the sort of like the category of the objects to walls, and then get the elements, not the element IDs. So this is what I'm trying to do. Now let's look at every step of this process. So we call the DB, let's actually write it exactly like inside this script. We call the DB filter element collector, and we pass the document object that we have created to it. What does it do is that it basically returns a filter element collector object. Let's not look at the internals of it for now for a second. This is a filter element collector object. It returns that to us and it assigns it to that variable, right? So inside this, what we have already set up is the document. So the source document, let's say, is already set up for that filter element collector. Now, there are many other properties on this object. As we can see when we go and look at the sort of like the filter element collector documentation, there are many other methods that we can interact with the filter element object. One of the most important things about many of these methods is that I'm going to use, for example, where element is not element type, something that we have used before. One of the very, very important things about these methods is that a lot of them return, if you look at the C# syntax, is public filter element collector, where element is not element type. It actually returns a type of itself. It literally, this method processes the information that we have given to it. In this case, it doesn't really need any information. When we run this method, it literally does some internal changes to the object and it returns itself. What's nice about this is that we can chain them like this. The only reason that I'm writing it in a different way is because I like to keep the width of my scripts to about 80 characters. It pushes me to use like more appropriate variable names and things like that, and sort of like structure the text document a little bit better so I can understand it later a little bit better. So I can do this and then do this as well, so I can understand that I'm doing this in 3 different steps. What's nice in Python is that for Python scripts you can use this character, the slash at the end of the line. This tells Python that because if that doesn't exist, this is a complete statement. Python doesn't really need anything else. There are no open parentheses or anything like that. By putting this at the end of the line, you're telling the Python processor that basically this line is not finished, so it has to continue. You don't have to do it on the last line, but every break in the line you want to put this break character in there so it knows that it has to continue. It's this is my preference. You might have other preferences. A lot of people increase the width of their scripts to about 120 characters. I like it simpler like this, especially for documentation and whenever you're publishing your scripts on the web and things like that. It kind of gets rendered in a smaller space and it's easier to read and follow. Anyway, so we were talking about these 3 steps. So we can chain this. So after the filter element collector, I'm using 2 methods. Well, in this case, in 1 method, the off category returns this object itself again. So the filter element collector, this is the constructor. When we run this, it returns this object. But when we say off category, let's say built-in category.ost walls. I actually had to put the DB in here to be very accurate. When you do this, this method is basically a method of the object that was returned by this, right? So to this point right here, you have a filter element collector object. But then when the object is here, you're running the off category method on that. So by the end of this, the off category will return a modified version of this object. So what it does is that it goes internally changes the state of this object, sets the let's say category for that filter element collector, and returns the same object. If you check the address space of this collector object inside Revit Python shell, for example, you'll see that it's the same address because it's the same object that's been just modified internally. So as you're chaining all these different filter methods, you are basically further down modifying the same filter element collector object that you have created in the first place. One of the other very nice features of this filter element collector constructor is that you can pass a view ID to it. So document and view ID will set two properties. What is the source view and the source view of the source document of that filter element collector. So it only works on the elements that are visible and owned by that view, basically, inside that document. These are the only two ones that you can really pass to the constructor. Everything else has to be filtered down using the filter methods like this. And we have used the off category before that, we pass it the standard walls category from Revit's API, and it would filter everything down to the wall category. There are a lot of, there's another very similar method like this that's called OffClass. Instead of passing the standard category, you can use the sort of like the .NET class to that object. So you can say to that filter element collector, so you can say OffClass. The thing is that if you're inside Revit, inside the C#, you can do it a lot easier. But when you're doing it inside R and Python, you need to import the CLR module. Oops, bad today. CLR module, and when you're using the OffClass method, you have to say CLR.get CLR type. So you're asking the common language runtime for the exact type of that object that you're passing it to, because you're not using an sort of like an instance, you're using a type in this case. And you can say db wall, for example, and that is the wall object within Revit's API. So if I do the Revit API doc, say wall class, so this is it. The thing about this is that the OffClass only works on the subclasses of the element class. So if you go into wall, you see it's subclass of host object, and the host object is a subclass of element. That's why you can use the OffClass to work on, collect all the walls this way. There are a lot of other objects in Revit's API that are not the subclasses of element. You cannot use the OffClass to collect those stuff. And it's very clear by knowing that this is a filtered element collector. This object is designed to collect elements and its subclasses. So this is another one of those methods that you can use. I'm trying to go through as many of these methods here and sort of like give you an overview of how this thing works. As I've mentioned before, the purpose of these sessions are not to basically walk through everything that's in the Revit API. I'm not trying to fish for you. I'm trying to teach you how to fish, basically. So what I'm really trying to achieve here is to give you a very good understanding of how these objects and how this API works, so you can find your way down the way and then do whatever you need to do for your scripts. So the off category and OffClass we talked about. There's another one that's off category ID, so you can pass an ID to it. A lot of this stuff you can just go inside the function definition in the documentation and see what type of input is required for it. It's an element ID that's actually category ID. You have to pass to it, and you can see the examples and stuff like that to see how you can get those category IDs and things like this. But from the stuff that we talked about here are the ones that we use daily and are the ones that are the most important. Sometimes you can't see the object that you want in the built-in sort of like the built-in parameter. Where'd it go? I think we deleted it. Yeah, the built-in parameter definition. So you can use its class to basically collect it. One of the ways that I do it is that I select that object inside Revit, and I use the Revit Python shell to see what kind of class that object is, and then I go find that name in the Revit API documentation, and I'll use this OffClass collector to filter my collector to that type of object. We talked about this basically providing a view ID to the filter element collector. If you already have a filter element collector I'm going to call it FEC from now on. If you already have a FEC set up with just a document, not a view, you can actually use a method which is called OwnedByView, and you can pass the view ID to it, and it would filter down the collector to the objects that are visible or owned by that view. So sort of like this is like an afterthought. If you don't have this here, you can use the OwnedByView method to do that. There are a couple of other ones that we have used before, where element is element type or is not element type. These really don't have any inputs. You can just apply them to the filter element collector, and it would modify the internals of it. And then where element is view dependent, for example, if you want to collect all the sort of like 2D elements on a view, you want to make sure that you apply this to your collector so it doesn't go over the model elements. You only want the stuff that are owned by that view, and it's view dependent, which means that they're 2D objects. Or if you want to only work with objects that are curve driven, like for example the profiles and things like that, that basically are based on a curve. Or railings and things like this. You can sort of like filter down your objects to this. There are the two methods that we are going to talk about at the end of this is the two elements and two element IDs. These are the ones that do not return a filter element collector object. So if you go and find those, they're here, yeah. So two element, these are very simple methods that just basically return all the filtered objects as just a list of elements or list of element IDs. So after you apply the two element ID or two element IDs, you can't really use any other methods, right? You can't use any other filter methods. Why? Because the return object is not a filter element collector. It's just a normal list. Obviously, you can use a lot of like methods of the list object, get the first element, get the length of the element and stuff like that. But it's not at this point you're done with your filtering basically. So that's why this is generally the last method that you use on your filter element collector. You filter down as much as you can, and then you turn it into a list of elements or a list of element IDs. You don't have to do this, but it's a good practice to get that list. Or you can use an iterator on your object that's also defined in the documentation. You can get an iterator for the filter element collector to basically go over one by one. So we talked about these. I'm just going to mark them so we know that we talked about these. And the reason that I'm not really going into deep into these because they're very simple. I'm sure you get them right the first time you use them. These are not that specific. They don't really need to have any input data. One of the other nice methods on this one is called excluding. It's a very simple. It needs a very simple set of data that is basically just a list of a collection or a list of element IDs. So basically you're saying if you have, like for example, you want to say filter all the walls except for the ones that are selected. You can pass the IDs of the selected objects as a list to the excluding on the filter element collector. So if inside the script you're here, you can say OffClass, let's say just that, and then you can say excluding and then selected wall list, for example, assuming that you have already collected the selected. So you can do this, and the filter element collector basically excludes, returns all the objects except for these ones. So it's a very good feature. And also there are two other ones which are super useful. They're called intersect with and union with. So you can do two different filter collector objects. Let's say you want a collection of, you want to work through a list of all the walls and all the doors. So you can create a filter element collector object that only is filtering down the wall objects because you applied off category to it. And then you can create another one, another filter element collector to basically return all the rooms. And then you can use the union with basically to combine these two into one single element collector. So these are great great features on the element collector object. So remember always to use intersect with and union with if you're sort of like combining two lists that you have, so you get one filter element collector. We talked about the OffClass, we talked about OwnedByView, and we talked about these two. There is an extremely important method on the filter element collector that we haven't talked about. Most of the stuff that we talked about, they're super simple. Some of them you can just know what it does by just reading the documents in front of it, like the first element returns that. The one that I really want to talk about today, and I'm sort of like calling it the advanced part, is this method. It's called WherePasses. So this is a much more general method. It requires you to pass a filter object to this. And based on the criteria of that filter, the filter element collector basically filters all the objects. So when you do WherePasses, filter element collector object checks every element that it contains inside its own definition, however you have filtered it down, through this WherePasses method to see if it passes your filter, the filter that you provided to it, and if it passes, then it would return it as a sort of like a passed element, and it would return it in its element list. So if you can't find anything that you can use here, you should use. But if you have a very specific case that you want to use something that's with a very specific filter to you, and we will do an example later. But just if you want to do that, this is the method that you want to use. So let's get into detail of how this works. This is the WherePasses function, the method on the filter element collector object. What does it need? It needs an element filter. So if you go dig deep into the element filter object, and if I open that, and if I go to members, you see that there are no constructors in this. Let me show you an example that does have constructors. See, a lot of these classes do have constructors. So you can instantiate, you can create new instances of these type of objects. The element filter doesn't, because this is a template class. This is like this is a class that you can't create an instance of its own. It's just basically created, so it basically provides uniform functionality to these subclasses that are created for it. So if you go through this, you can see that the element filter has 3 different subclasses. These subclasses, they might be their own template classes. In this case, most of them are. But basically, what this system means is that you have a sort of like a tree of many different types of objects that have a shared parent, which is the element filter, that you can pass to the WherePasses function. I'm going to show this to you in a little bit more detail. For example, let's talk about the example that we want to work on today. Let's say I have a bunch of walls in a model, and I want to collect the ones that are of height 10 feet, for example. What I can do is that what we used to do before, the script that I actually showed you, that's what it does. So we don't pay attention to these 2 pieces. I'm adding these for timing only, so we can time the 2 scripts against each other and see which one is faster. I have to import basically all the necessary imports. Get all the walls, go through the walls, look up the parameter, which is the unconnected height, check its value to make sure if it's 10 or not, and then if it's 10, append it to the list, and then use the UI.selection, set element ID, and I have to create a list because this is a .NET element, the .NET method, so it needs the .NET type of list. So I have to import that list from the system collections generic. You should know these basic generic sort of like data types in the .NET platform. That list is of type DB element ID. It means that the list only contains element ID objects. And then that's why I'm passing on the wall ID to this list. So it has the IDs of all the tall walls that I wanted. And then I pass that to this set element, and it would basically select all those elements in the Revit model for me. This is the way that we talked about it to this point. Now we want to use the more advanced system. We want to create a filter for the WherePasses function so that the filter element collector does the job of filtering all these elements for us instead of us iterating over 1,000 different walls and figuring out which one is of height 10. So let's take a look at that. in the next 5 minutes, I'm gonna a little bit confuse you with all these, different hierarchies of things that are or objects that are inside this element filter. But don't be intimidated. It's not as hard as it seems. There are plenty of examples in the Revit API documentation that you can use also to do this. Okay, let's say you want to do this. We want to basically filter down the walls that we are filtering to the ones that have the height of 10 only. Okay, so we have three different types of subclasses in this. What are these? Let me grab that sheet again. Where did that go? It's here. Okay, so element filter has three basic, very broad subclasses. One is the quick filter and the other one is a slow filter. Just by reading the name, you kind of have an understanding of what they do. This is a quick filter that quickly filters a bunch of objects, and this is a slow filter that needs more time to do things. But why is that? In the previous sessions that we talked about databases, one of the things that I really didn't touch upon because it's a little bit more complex subject is database indexing. So let's say you have a database like this that has the customer information with a primary key, and every customer has its own unique customer ID. Now, let's say one of the things that we do with this database is listing all the customers that we have in different cities, and also sort of like listing all the customers based on their family name. So customer data has a lot of different properties. But these two properties, the city that they are in, and their family name are the ones that are more important to us because of the application that we're using this database for. It could depend on whatever else that you do. The database designer picks the database basically columns, the fields that need to be indexed by the database management system. Excuse me. So in this example, this database management system is indexing the cities and it's indexing the family names. What does it mean is that the database management system, these are not the tables that the database designer creates in the database. This database designer basically just creates this, and it tells the database management system to index these two fields. And what the DBMS does is that it goes in and creates like internal tables for all this information and says, okay, Clark, well, both of them are, and it points to the ID of that customer, or Chicago, and it points to the ID of that customer. So when you ask the database management system to give me all the Clarks or all the Joneses that live in Chicago, it's a very fast query for the database. Why? Because it's already indexed everything. So you can just look through this table and look through this table and return the result without even touching the main database, because you're not really querying any other information. But if you say, okay, so give me all the Joneses and give me all the Joneses at Chicago or in Chicago, and then sort them by their first name, what it has to do, it has to go through this list, go through this index, grab all the customer IDs that are Joneses that live in Chicago, and then it has to go inside the fact table or main database table and look up their first name so it can sort it based on that. The first query that we did is called a quick query. Why is it quick? Because database is indexing this information. So these are the information that lives in database's memory when it's running, and it's super fast. But when you want to do more information, query more information about the object, we call it sort of like expanding the object. So the DBMS has to expand that object, that entry in the database, so you can read more information about it. The way we can sort of like apply this scheme to Revit is that, let's say you have a room object. If you want to query the room's I don't know, mark or ID or something like that, that query might be very fast. But if you want to know its area, Revit might have to go inside, need to expand that area object, get all its properties. Maybe, I don't know, if it's bound by a bunch of walls, maybe get the IDs and information about those walls as well, and then return you that information, in most cases, calculate and return you that information. So it could be a lot more complex, and that's the main reason and the main difference between a quick filter and a slow filter. If you go inside and expand these two, so if I open the quick filter and slow filter, I've opened these in two different pages, you can see that these are also template classes. You can't create just a quick filter instance. You have to use one of these. So there are a bunch of different subclasses of the quick filter that allows you to quickly filter information from Revit's database. One of the nice things is that, for example, bounding box contains point filter. So if you have a point and you want to know what objects are in the vicinity of this point, that's one of the good ways to do it. Any object or any element that has a bounding box that this point resides on inside it, it would be returned as the filter. These are the stuff. This is the functionality that you don't see in the main filter element collector class, because these are a bit more complex, and you have to create filter classes and passes it through the WherePasses. And in some cases, creating these, in most cases, creating these filter classes takes many steps to be able to do that. Because what you're really trying to do, you're trying to explain to Revit, to the .NET platform, basically, this logic to look up that parameter and look up its value and do the comparison. I want to make sure that's equal to this, and then blah blah blah. You don't write it as a script. You basically are trying to explain that logic by building many different objects to the Revit filter element collector object basically. And we'll go through this. I'll show you how exactly this works. So this is the main difference between the two. Make sure you go, if you're doing one thing on this filter element collector object, make sure you take a look at all these main methods and make sure you look at the filters that are available to you. The internals of these filters are constantly being improved by Revit, the programmers at Autodesk. And one of the nice thing about this is that if they figure out a way to make one of these faster or add more in here, potentially any of your scripts that are using these filters would get faster, which is a very nice feature. One of the other ones in the subclasses of element slow filter, one of the ones that we are going to use today is the element parameter filter. Why is it this slow? Because Revit has to expand that object to be able to grab the value of that specific parameter that you're looking for to do its job. So this is sort of like the slow filter object, and the reason that I'm comparing it, I'm using a slow filter today, is because I want to match the script that I've written in here, because we are really doing a slow job here of filtering this down, reading the parameter value and things like that. And I want the other example to do exactly the same thing, to be a sort of like a more fair comparison between the two. So we're going to use one of those. Make sure you take a look at all this stuff in here. Area filter, area attack filter, they're really, especially for structural and mechanical engineers, these are the ones that are super helpful. Could help you a lot with filtering down your information. So okay, let's take a look at, I'm going to close this. Well, let's actually keep it open. Let's go take a look at the element parameter filter that we want to use today. Okay, so far the intent for me is to create an instance of a subclass of the element slow filter, which is called the element parameter filter. If I can edit this filter, and basically pass this to the to my WherePasses method. And I'm not writing anything else behind this, because you already know that WherePasses belongs to that filter element collector object. So yes, so we got that. We can pass this to that. And to do this, the element parameter filter needs its own set of inputs that we have to provide to. One of the last thing that I want to mention here is that we are able to pass this to the object, to the WherePasses, although it says element filter, but because this is a subclass of this and this is a subclass of element filter, all the objects that are subclasses of this could be passed through as this, because they, what makes sure that's one of the basics of the object-oriented programming, that these objects you can use instead of this type, you can use one of the subclass types, because it has all the properties of that sort of like parent object by design. Okay, so let's look at what information do we need to provide to element parameter filter to basically tell Revit that we want to filter based on the value of the parameter unconnected height, and we want to set it to make sure it's equal to 10. Okay, so let's take a look at this. What we want to do, there's a really good example in all the different, C# and VB.NET languages. I'm not going to go through this. You can always take a look at this stuff. It might be, if you're used to Python, it's a little bit harder for you to read this, but over time you get used to how C# is written and how to read these examples. But anyway, let's do this. What I need to do is that I need to take a look at its members so I can find the constructors. Okay, so it says I need to pass a filter rule to it. There are a bunch of other options, but generally the first one is the one that you want to use most of the times. Okay, so I have to pass a filter rule object to it. So let's say I'm not going to do that trick in here. I'm just going to write filter rule. Make this wider. Okay, so we have to pass a filter rule object to this. So let's create a filter rule object. And we have to figure out what information do we have to provide to the filter rule object. And we want to pass this to that, basically. It's not as nice as it should be, elegant as it should be, but it does the job. Okay, so filter rule. I'm going to click on this, and I'm going to click on filter rule. So it will take me to the filter rule class documentation. And I can see that, oh, this is well, let me actually go into members. I see, oh, there are no constructors. So this is a template class. So I can go back and see what other subclasses it has. Filter category rule, filter inverse rule, filter value rule. This is what I want. I want to filter the parameter, the objects, based on a value of a parameter. So I use the filter value rule. Okay, so I need this. So I want to pass this to the, well, actually I want to create a filter value rule. Okay, so I want to create a filter value rule. Let's see how we can construct one of these. Oh, it doesn't have any constructors. This is also a template class. So let's see what other things do we have. Filter numeric value rule. We don't have a string value. Our value is a double, is a floating point number. So we want to use the numeric value. And for the sake of, because I don't want to bore you with this, so this is also a template class, and there are subclasses to it: double, element ID, global parameter association rule, and some of them, like this one, I've never used before, but I'm sure, if you look into documentation, it should be pretty simple to figure out how it works. But what we care here about is the filter double rule. And let's make sure that this is not a template class. I can say, just by looking at this, I know that it's not a template class because it doesn't have any other subclasses under it. So, okay, there we go. There's the constructor, and it doesn't really need any information in it. That's nice. So I can just create filter double rule. Okay, so I can just create a filter double rule, but there's got to be a way of telling that. Let me actually look at my script. See, what did I do? Oh, there are. Where are the inputs? Huh, okay. That's funny. They're not listed here. Anyway, there's a bigger list. That's why they didn't list all the inputs in here. Okay, so we do have to provide some inputs. That confused me for a second. Okay, so there are a couple of different things that we have to pass to this to create the filter double rule. One is the filterable value provider. Some of these names are a little bit funny. You kind of have to get used to it, but they're a little bit more complex because we want to step by step explain the sort of like the steps of evaluating that logic basically to Revit. So the first object is a provider. What does it do? It does is that it provides the value of a specific parameter to the double rule filter. So this goes into the object that's been passed to it, as in this example, a wall, grabs the value of the unconnected height, and then it passes it on to the filter double. And then we have to use another object, which is called the numeric rule evaluator. In this case, we're going to use, that's also a template class. We're going to go through it, and we want to check for equality. So we're going to use filter numeric equals. So we're going to use that, and we're going to pass that, and basically this tells this filter that, okay, we are checking for equality. So get the value of that parameter. We're checking for equality, and that's the other value that we're going to do. So this whole thing basically is doing the job of this little piece here, grabs the value of that. We are checking for equality, and the other one is the value that we're checking against, right? So this is the value this is the rule value they're checking against. And there's another one that's called the epsilon, which is the sort of like the plus minus that we're checking against. I'm just providing the value from the example, so that really doesn't affect it that much. You can use 0, I guess. Okay, so we need to create a filterable value provider. How do you do that? Let's say, and I forgot to do these stuff in here. So let's say filterable value provider, and what was the other one? Filter numeric rule evaluator, and then the value, which is in our case is going to be 10, and then the epsilon or whatever, whatever the plus minus is. So we need to figure out how to create these two objects. Okay, let's do another one of these in here. Okay, so filterable value provider class. How does this work? Let's go. Oh, it's a template class. We need, oh, there we go. Parameter value provider. So it's subclass of that. We're going to use that. It provides the value of a parameter. And how do we create one of these? Go to members, constructors, element value provider. Sweet. We have to provide a parameter ID of a parameter into this, basically, this parameter value. So I've already read the examples, and the way you do this is use the built-in parameter enumeration inside Revit's API, and I'll show you how it's written. And we're going to go through this enumeration and find the unconnected height, which is this, and this is how we tell that parameter filter rule, this is the parameter we care about. We want to provide the value of this parameter from that element. So the way it basically gets written in the script is this. DB built-in parameter that we talked about, wall user height parameter, we're going to pass that into an element ID object so we can get the element ID of that built-in parameter, and we're going to put it in our variable, which is called the height parameter ID. And then we're going to pass this into the parameter value provider that we talked about. So the parameter value provider that we talked about, I lost it. Yes, it needs an element ID, right? So that's what we're going to do. We're going to get the built-in parameter, the parameter we're looking for, pass it to an element ID, gets its element ID, and pass that into the parameter value provider. And that is our parameter value provider object. So we figured out how to create this object, right? I'm not going to go through this because at this point I really have to show you the script. So we figured out how to create this. And then the next one would be the filter numeric equals. This really doesn't need any inputs because it's just name says that what we want to do. Filter numeric equals, if we go through this and then go to constructors, members, constructors, it doesn't need any inputs. You just have to create an instance of this object and pass it to the filter double rule. So we told the filter double rule, grab the value of that specific parameter we're looking for, do the equality check with this value within this range. So this is what happened. We created that parameter value provider, the first one, filter numeric equals, filter double rule, we passed these two, and then we passed the value that we're looking for, and 1 to the power of -6 is just a tiny number as the sort of like the range, which is a tiny range. So we say anything that's super close to 10, pick those. And then at the end of this, we get the filter double rule, right? So what do we have to do with this? We have to pass it on to element parameter filter. So we do that. We get the filter double rule. We pass it on to the element parameter filter. And then the parameter filter, what do we do with this? We pass it, we're done. We pass it to the WherePasses on our filter element collector. So at this step, we get that element parameter filter, and we pass it to the WherePasses method of the filter element collector object that we have created. Right? So we do this. See, I'm not even filtering for the walls anymore because that specific parameter that we picked says it's a wall parameter. So Revit already knows that this is a wall parameter. It doesn't look into anything else. But that's why you don't really need to filter down your filter element collector to off category of walls only. So at this point, after this, we have a list of the filter element collector is returning a list of all the walls of height that equals to 10. And then once we're done with this, we turn it into the element ID, a list of element IDs. We grab that and we get it to the set element IDs. Notice that I don't need to create this list object again, because I'm not because this list that we created is a Python list, and we have to convert this list into a .NET list that we need to pass to this. But the list that we got from the two element IDs is already a .NET list, so we can just pass it on to the set element IDs. So this is the main difference between these two scripts. You see, this feels a lot more complex when you're writing it down. But here is the benefit of it. This is the collector. So if you go into, if you update your pyRevit on the pyRevit tutor, I'll put both of the scripts in here. The collector is the first example. The better collector is the one that we created. And if you compare these two on the time function, see the better collector almost runs twice as fast as the older one, as the previous script. Yes, we took a little bit of time, more time to write this, but imagine you're running this on thousands of walls. Your script is going to be so much faster and use a lot less memory. This helps you. This is the major difference between a good software and a bad software. In this example, I'm not saying this is bad. This is a script that does its job, but this is a much, much better script. It talks to Revit in a sort of like better, more advanced system. It lets Revit handle those filtering of the information. It basically it's a better friend to Revit's database management system. If at any time in the future the Revit programmers speed this up, let's say improve the efficiency of this object and make it, I don't know, twice faster, then your script is going to be twice faster as well. So it's nice that you're making it dependent on something that's constantly being improved and things like that. So if I run this script, obviously you're going to get different numbers every time you run this, depending on the, see, it's a little bit slower now. Depending on, I'm running it in a virtual machine and things like that. So it's going to be a lot faster on your machines. But that's what it does basically. This is really what I wanted to talk to you about. I'm almost done with all these things that I wanted to mention. There's only one last piece of information that I want to give you, and we didn't touch upon the last type of the element filter. We talked about the quick and slow filters. There's another one that is called the element logical filter, and it has two. I'm going to close these actually, so we can go and talk about that on the BuiltIn parameters. Okay, so element logical filter. It's a subclass of the element filter class. So if you go into this, you see there are two logics, and an or. What's nice about this is that, let's say you created one of these complex objects, and you have another one, because you're checking for two parameter values, and it has its own structure and whatever you have created. Let's say this is filtering for wall height, this is filtering for another thing. You can create because still remember that these parameter filters are a subclass of element filter, just like this logical filter. So what you can do is that you can create the logical filter, let's say and filter, and pass these two to it. I'm going to say just X and Y, whatever, and pass these two to it. And it would combine these two logics in an and then you can pass it to the element filter. This is what element logical filter does. You can combine multiple, and you can chain them together, basically. Because they're all subclasses of this. So you can potentially, I haven't tested this. I don't know if it works honestly or not, but you can even chain these, and then combine this with another parameter or any other type of filter that you have, and then pass it to this, and maybe you can say this one is an or whatever. You can create a complex logic of comparison and getting different parameter values or other rules that you want to create and pass them on combine them into a logic of or and then pass it to WherePasses. You can see this could get very complex after a while, but imagine this is right, like if any of you know SQL language, this is writing a SQL query to the database. You're basically describing what, how the database management system should filter the information that's passing on to you. This element logical filter is a simple thing to use, the and. If you go under constructors, for example, you just have to provide it a list of element filters, as many as you have, and it just provides an and logic between them. So all of them should be correct. If you're passing to and, all of them should be correct for it to pass, or if it's an or, either of them should be correct for it to pass. It's a simple object, but it's super useful, especially when you're combining the logic. So just knowing this, you can imagine how complex logics you can create using these. And you can basically filter that. You can do 90% of what you want to do in terms of filtering just using these methods. The 90% percentage that I said, this is not something that I've tested or anything like that, but I'm just saying that there's so much that you can do with these filters to be able to dig down into the data and then tell Revit basically, tell what kind of data do you want and how it should filter it. So get into the habit of understanding this. And then what's nice about this is that, let's say in your company, this is something that you do that's very specific to you. You can always turn this into a function and put it somewhere on get tall walls, for example. You have to write this only once. So you can just turn this into an object that basically just works like that, and then put into a function. I'm sorry, and then put it in your library, and then later on in other scripts, if you want to use it, just import that function and use it. You don't have to rewrite this every time. Just know the functionality that is deep into this filter element collector object, so you can get more efficient data out of your Revit. One last thing that I want to talk about is the chaining of these collector classes. So we talked about the quick and slow. The only thing, I don't want to dig in too deep into this, and we talked about the steps of doing these sort of like chaining of this. So I'm going to write this as a sort of like a pseudocode as an example. Let's say I have a slow filter in here that I'm applying. This is not an actual method, I'm just using it as an example. And then I have a quick filter here. Well, just by looking at it, you understand that you're not really gaining any efficiency because you're doing a slow filter before a quick filter. You're already slowing down your filter. Make sure anything that you're doing that's a quick filter or standard methods of filter element collector, use them first. Filter down your data as quick as you can before you get to the slow filters or slower methods. This way, you just reduce the amount of data for the slow filter to process. This is really how you benefit from this extra speed. I hope you enjoyed this, and I hope this would help you creating better scripts for. I'm actually going to undo this so I can save it in the. Yeah, I hope this helps you create more efficient scripts for your programs. Obviously, as we talked about this, Python for Revit is just in a scripting language. We want to do a lot of times we just want to write a script to get the job done quickly and get the objects, and it's not something that we want to do like over time with many different things. But if that's the case, make sure you use and benefit from all these improvements in speed and efficiency and everything else that's built into the Revit API. One last thing that I want to mention is that if you go through the pyRevit scripts that I've written, you find a lot of them ridiculously badly designed, because that was from like 2.5 years ago, and I didn't know this kind of stuff. So you find a lot of scripts that I'm doing this in it, and it would potentially like slow them down. But in most cases they work, and that's one of my goals for pyRevit version 5, to kind of like go through all these scripts again, and based on the new knowledge that I have, kind of like rewrite them and make them better and faster and everything else. So I hope you have enjoyed this. I hope you find it useful, and see you in the next section.